Okay, my name is Grant Wilcox with TriQuint Semiconductor. I am a product line manager supporting the defense unit, primarily with GaN products, but we also do quite a bit of gallium arsenide products as well. Today's presentation will be primarily focused on GaN product solutions that TriQuint's bringing to the market, both primarily on the defense side. I'll talk a little bit about the commercial products that we're also releasing over the next couple of weeks as well. So please ask questions as I go along. I have about 40 minutes of presentation, try to get down into about 15 or 20, so I will go fairly quick, but I'll be staying afterwards to answer additional questions. You can talk to your Richardson representative if you want to for further questions, as well as head over to the TriQuint booth where I'll be for the next few days as well. So let's get into it. Gallium nitride development has been ongoing for over 10 years now. Most of it's been technology development, technology maturation, getting it the higher yields, better performing, things of that nature. So the market's been really ready to have a lot of products delivered to the market. We are in the process of doing that. You probably saw our press release a couple days ago highlighting a long list of products across several markets like gallium nitride. So TriQuint's really bringing to the market the promise that gallium nitride technology has brought to the market as well. So what markets are we supporting? On the defense side, radar obviously is primary with the high power density, high efficiency that you get with gallium nitride. Electronic warfare is really in the wheelhouse of gallium nitride with the broadband power and broadband efficiency that it brings to the table. Military communications, SATCOM, data links, military radio, TriQuint's supporting all of those markets with our products. On the commercial side, high-powered VSAT. Actually, we released a couple of products in our GaN 15 process, our 0.15 micron technology, that we're highlighting at the TriQuint booth, along with a customer product that they combine several of those mimics into a 150-watt saturated Ka band VSAT amplifier. 150-watt saturated, 60 watts linear. So an incredible performance achievement with that product. As well as cable TV, we have a power doubler that we recently released for our cable TV product line. And the telecom base station has been engaged with gallium nitride for some time now, and TriQuint is participating in that market as well. So focusing on the right products. Across the board, we have transistors, matched mimics, hybrid amplifiers, all addressing these markets that I've been mentioning. On the transistor side, just to go through a brief rundown, general purpose. We have transistors anywhere from DC to 18 gigahertz right now that are in bare die form. On the package side, we have it up from DC to about 6 gigahertz and below. S-band, C-band radar on the package side, avionics, communications, military radio, things of that nature, all being supported with our transistor product line. On the communication side, C-band, X-band, KE-band, SATCOM applications, VSAT applications, which I mentioned a second ago about the KE-band VSAT that I had mentioned that we're highlighting at the TriQuint booth. Some using our market-leading 0.15 micron technology, others using our released quarter-micron technology. And again, military radio, VSAT, common data links, things of that nature are being supported with TriQuint's product line. Radar, both on the transmit and receive side, we have pretty much all the bands covered. S3Ka band for radar transmit, as well as highly robust LNAs that we're releasing this week as well, 2 to 6 and 6 to 12 gigahertz. And I'll talk a little bit more about that because there was power amplifiers have been supported by gallium nitride for a few years now. There's been a lot of excitement behind the release of GaN LNAs and what they bring to the table with highly robust levels of input power. And I'll get into that a little bit. Electronic warfare It's basically the wheelhouse of GaN, broadband power, broadband efficiency, and TriQuint's bringing to the table several PAs that follow in line with that. And on the commercial side, as I said, base station's been involved with GaN for some time now. TriQuint's just released a cable TV power doubler, high power VSAT that I mentioned, high efficiency, high power amplifiers. TriQuint has it. So a little bit more details on the products, and again, I'm going to go through this fairly quickly. And more detailed questions, I can support those after the talk, either here in the Richardson booth or in the TriQuint booth. So the idea here is to give you trends of where we're going with our portfolio, where we're going with the market support. So here you see the GaN package transistors. This is a subset of what we offer. Primarily the most recently released product line. We have another list of products that's already released, and you can see that on our website. But you can see here, the package parts are limited up to 6 gigahertz. That's primarily a package limitation, not a die limitation. And you see the DC to 6, it's just a die in a package. That's all it is. But you see anywhere from 9 watts up to 25 watts, our power capability, drain efficiencies 50% or better. Where you see the 3.5 gigahertz or 1.6 for the bottom there, there's a pre-match on that transistor that allows the customer to better match to that particular frequency point. So you can see the much higher powers as you go lower in frequency, all the way up to 285 watts for L-band support. So again, these are in the process of being released, are planned to be released here in the next few months. So getting into the match components, I'll go from S-band all the way up. Starting with S-band, we have several PAs that we're releasing, both export friendly as well as ITAR controlled. So for the international crowd, we have full 2.7 to 3.5 gigahertz components. Really, depending on bias condition, you can operate it anywhere from 10 watts up to 30 watts, and I'll show a little bit of that in a second. But efficiency is up to 60%. So again, a very high efficiency parts that gives you the flexibility to play around with the drain voltage to get to the power level that you need. A little bit more on the export controlled side is 3 to 3.5 gigahertz PAs, one operating at 80 watts and the other operating at 100 watts. So very good high power PAs. But the key here is the efficiency numbers that we're achieving, 55% efficiency across that band and at those power levels. So very high performance that we're achieving here. This is bare die. We do plan to package these parts later on in the year. So again, the target application of these is S-band radar. As I mentioned, the lower power parts, the 2583 and 2585, are exportable. And this chart gives you an idea of how much room you can play with the power, depending on the bias. This is the higher power version. As you can see, anywhere from 25 volts to 32 volts. You can vary the power level, output power level, anywhere from 18 watts up to about 30 watts. Now with the lower power version, you can fill in the 10 to 20 watt area on that chart. So with both amplifiers, you can support anywhere from basically 10 to 30 watts just by bias. So moving up to X-band, we support a variety of markets with our X-band product line. Again, radar, electronic warfare, communications, in a variety of forms. Most are exportable, as you can see with the 3A designation on the export column. The top one will be ITAR, just given the fact that it supports all of X-band at these power levels. So the TGA 2590 is 6 to 12. It can support by itself EW applications. It can support radar. It can support some comm applications for TWT type replacements. The data you see here is for CW. This was designed for a CW application. So we're achieving 30 watts, 30% efficiency over the 6 to 12 band. The 2586, the second one down, is a SATCOM amplifier achieving 60 watts over that band at 30% efficiency. Again, this is a hybrid approach. It's a single stage GaN hybrid amplifier meant for TWT type replacements for SATCOM. Then we have a few 9 to 10 gigahertz PAs targeting narrowband radar type applications. Of course, there's weather and marine radar that's targeting right at 9.4 type area where these PAs would support quite well. So different power levels. The 2624 starts off at 20 watts, then we go up to 40 watts, and then ultimately with the 2312 we go up to 60 watts. So note the power added efficiency numbers for the 20 and 40 watts. We're at 45 to 50% efficiency. Again, that's the best in class for that band. The 2312, 60 watts at 35% efficiency. So very good performance to support those narrowband radar opportunities. Then we move up to the 10 to 11. Good international interest in the 10 to 11 gigahertz band. We have two products, one 16 and another 30 watts. But again, achieving 45% efficiency with good gain across that band. So again, a lot of next band opportunities, both domestic and international, that this product line will support. EW, radar communications. Most of this is pulsed. You can run it CW without a problem, just backing the bias down to manage the power dissipation numbers. This performance that I mentioned here, from the 2586 down to the 2623, is all pulse performance, but you can run in CW if your application requires it, with just a little bit of degraded performance. So here's an example of the 2622. That's the 9 to 10 gigahertz 40 watt PA. As you can see, it's fairly flat power across the band, dipping right at 10 gigahertz. Power added efficiency, a good solid 50%. Toward the upper end of the band, 45% toward the lower end. So good solid performance over the 9 to 10 band. So moving up in frequency, KU band. The PAs that we developed for this band were targeting the common data link opportunities. We also had some VSAT opportunities that we were supporting with the 2579. So good international interest with the 2579 for the common data link and VSAT. We are, if you have KU band interest, there's other work that I don't have on this slide that we are doing in KU band. So I'm not ready to show it at this point, but I definitely want to talk to you about any KU band activities that you may be involved in that these parts can support, or you need some bearing of these parts. So moving on to the wideband products. This is, as I said earlier, really in the wheelhouse of gallium nitride, broadband power, broadband efficiency that the TriQuint products, as you can see, definitely supports. Starting at the upper end, the 2540, it's the 30 megahertz to 3 gigahertz 10 watt PA. That in the past, actually that was our first packaged GaN product that we released about 3 years ago. Supports both low band EW as well as some radio applications. The next one is the 2237. It's really a replacement for the 2540. Looking at a more cost-effective, smaller solution to cover that low band, the low band opportunities. That is currently in development. Then you move into more of the electronic warfare, jamming type of applications. The 2573 2 to 18, achieving 10 watts across the band. 2576 has been a very good international product for us, achieving 30 watts across that band, supporting both EW, counter IED type applications, some radar applications that we're engaged with, as well as some WildMax opportunities that have come up recently. And then we have the 2578. So there's a lot of the markets basically, they love the 2576 operating 2.5 to 6, but they really wanted that 2 gigahertz coverage. So we developed the 2578, basically targeting the same performance as the 2576, but achieving that 2 gigahertz bottom end. And the data looks I'll show a data plot here on the next slide, but the performance is looking very good on that part. Then the 2590 that I mentioned a little bit earlier on the X-band slide, again 6 to 12. This data right here is CW data, 30 watts, 30% efficiency. You can definitely use it for pulsed applications, probably get 40 to 50 watts out of that part under pulse conditions. So again, the 2590 can support a number of applications, EW, radar, communications. So on the 2578, I definitely want to highlight this because unfortunately it was missed in our recent press release, so I definitely want to get it in front of you now. This covers full 2 to 6, as you can see. The curves you see there is across voltage anywhere from 25 to 30 volts, 25 being the red, 30 volts being the pink. So running at 30 volts, you can see on the right-hand side, you don't really take a hit in efficiency. You still have good efficiency. Even at 30 volts, above 35%. So from a thermal standpoint, you can still run it at 30 volts and you can get close to 40 watts CW operation. So again, radar, EW, communications can all be supported by this product. So moving up in frequency still at Ka band, Parker just released our 2 PAs for VSAT. TJ 2594 and 2595 is a 5 watt and a 10 watt respectively. PA to support the VSAT opportunities. We actually have a demonstration, not a lab demonstration, but a connectorized amplifier by one of our partners using the 2595, and it's achieving 150 watts per sat with 60 watts linear over the 27 to 31 gig band. So there's a lot of excitement behind what this product is bringing to the Ka band VSAT market. So this is an example of the 10 watt that you see on the screen. It's a fairly flat PSAT of 10 watts across that 27 to 31 band, and good gain at around 30 dB across the band. So you can see by the picture below us, it's a balanced configuration. The 5 watt is simply the single-ended variant of this product. So moving away from the GaN switches, so as I said, if you have amplifier needs that you saw interest in the previous slide, please get with me afterwards, or your Richardson representative, or come over to the TriQuint booth. It's just across the hall. We can talk in more detail about the power amplifiers that we're offering. So moving to the GaN switches, we have a growing family of GaN switches. We've had 3 switches out in the market for about a year now. A DC to 6, 12, and 18 gigahertz switch at 40, 20, and 10 watt power handling respectively. When we put out the 40 watt 6 gig switch, we had a lot of people ask us that, tell us that's great, but when are you going to have a 100 watt version of that? Well, we've developed the TGS 2355 at the bottom of that table to meet that need. So that is currently in work. We have some development still left to go on that, but we expect to have a functioning 100 watt switch here in the coming months. Most of the applications for this product family has been TR, transmit and receive, radar switching, high power radar switching, as well as instrumentation applications. So LNA products. As I said, a lot of customers out there have been using GaN amplifiers for some time now, but not GaN LNAs. So there's been a lot of promise on what GaN LNAs bring to the table. GaN achieves the same noise figure, or equal or better noise figure than the equivalent gate length in PGAN. So our quarter micron GaN is getting as good, if not better noise figure than our quarter micron PGAN. Same thing for our 0.15 GaN. So we're achieving the same noise figure performance that customers are used to seeing with PGAN. The benefit is the input robustness, where PHIP LNAs require a limiter to protect it from high input powers. GaN will give you that benefit of possibly not needing the limiter. And we have two limiters, two LNAs, the TJ2611 and 12, covering two frequency bands. 2611 is 2 to 6 gigahertz, 2612 is 6 to 12 gigahertz. You can see we're still getting good noise figure. The 2 to 6 is 1 dB noise figure, good gain of 25 dB gain, good linearity of greater than 30. It actually picks up about 35 dB for TLI. On the 6 to 12, achieving a little bit higher noise figure at 1.5 with equivalent gain and TLI characteristics of the 2 to 6 gigahertz limiter. We're still in the process of fully characterizing these LNAs. We have taken some data from a robustness standpoint in the 6 to 12, and we pushed 3 watts easily into the 6 to 12 LNA without any issues. We did push it up to about 5 watts where we started seeing some issues there. But it looks like it can easily handle 3 watts of input power, which is order of magnitude more than what an equivalent PHIP LNA could withstand. So obviously the input power robustness is dictated by the input periphery of the LNA, so you can beef up the target for these LNAs with noise figure was to achieve the noise figures that you see here. We can sacrifice a little bit of noise figure to beef up the input periphery and further increase the robustness level of LNAs. Now, what it gives you by increasing the robustness is the possibility of removing the limiter from your receive channel. If you remove the limiter, you basically remove that extra noise out of the system. So you're improving your noise figure, your system noise figure by 1/4 to 1/2 dB just by getting rid of your limiter, if you can do that. So here's an example of a chart of the 2 to 6 GaN LNA. As you can see, the P1 dB point is around 21, 22 dB, P1 dB. So that is at room temperature and cold. Once you go hot, it drops to about 20 to 21. So it don't take too big of a hit on the temperature. Noise figure, you can see at room temperature, it's roughly right at 1 dB. And then when you go cold, it goes down to 0.4 dB. Hot is 1.4. So good noise performance, good P1 dB performance, good linearity for these switches. Here's the 6 to 12. Again, you can see P1 dB levels of 20 dB across the band, noise figure levels at 1.5 at room temp across the band. So again, good power performance, good linearity, good noise figure, and a highly robust product. Possibly for any given system, you may be able to remove the limiter, further increasing the system noise figure, reducing the bill of materials for your receive channel. So, as I said, we're doing a lot of GaN products. That's what this pitch was mostly about, was showcasing the GaN products that we're pushing out there. I invite you to, as I said, talk to Richardson, talk to TriQuint for more details on any of these products that you've seen here. I do want to highlight some of the gallium arsenide products that we're pushing as well. Again, we want to be your complete solution provider, not just the HPA, but all the supporting functions as well. So a lot of those supporting functions will come in the form of gallium arsenide products. So you can see here we have a family of S-band and wideband LNAs in gallium arsenide. From an S-band standpoint, the 2613, 2614 is high linearity, high gain LNAs. And the 2543 is actually an integrated product. It has an LNA, it has a wideband LNA integrated with a wideband limiter integrated with wideband LNA, all in a surface mount package. So you get good performance at 2 dB noise figure with good gain control across that band. We are recently releasing a 6 to 18 gigahertz phase shifter. This covers 6 bits. As you see, extremely good performance for a 6-bit phase shifter over 6 to 18 bandwidth. RMS amplitude error of 0.7 and RMS phase error of 6 degrees. Actually, that should be less than. We'll change that over. Insertion loss should also be less than 10 dB. So very good performance for a wideband 6-bit phase shifter. And then a general purpose gain block with the TJ3500. Again, good gain across the 2 to 16 band. And here's a graph of the 6 to 18 6-bit phase shifter. We also plan to offer it as bare die, also offer it as a packaged component, and when further plans to integrate it with the serial parallel converter for use of integration into your system. But you see here, phase error is less than 6, amplitude error less than 0.7, loss less than 10 dB. Very good performance, world-class performance for a 6-bit phase shifter of that bandwidth. So we have a growing list of limiters as well. The first three, the TGL2205, 6, and 7, are recent high-power limiters that we developed using our VPN process. Fairly low band, 2 to 6, roughly 2 to 5 for some others, achieving anywhere from 30 to 50 watts CW power handling. That pushes up to 100 watts of power handling under pulse conditions. That 100 watts was confirmed with a 168-hour operating life test, which they all passed rather easily in those conditions. We basically stopped the test at 168 just because didn't have the bandwidth to keep the test going. Two other limiters that we have in process is the 2208. It's basically our 2201 die limiter, which we packaged into a surface mount ceramic package. So that's a package limiter operating from 2 to 20. Again, CW rating at 5 watts. Then we have a Ka band limiter that we recently released as well, covering 30 to 38 gigahertz. Again, rated at 5 watts across that band. And that's it from a product solution standpoint. Again, the majority of our products are gallium nitride based. We are pushing a lot of gallium arsenide products as well from a supporting function because TriQuint wants to be your complete solutions provider for all the markets, EW, radar, communications. We're pushing the products out there to support those applications. And we welcome your feedback, we welcome your questions. So I'm available. I'll be available here to take any further questions as well as across the hall at TriQuint booth. So with that, I thank you for coming and hopefully talk to you soon.